Okay, my friends, welcome to log day 2. Okay, can I have somebody raise their hand and tell me if they figured out the first pattern from what they got in their table? Josh?
Log of x plus log of y is equal to log of x times y.
That's correct. Anybody else get that? Can I see? If you raise your hands, x times y. Good job, guys. That's your first log property, okay? So, if you have them split in 2 logs, you can combine them into a single log with multiplication. So hopefully the decimals you got when you guys typed them in that one, those two were the same, right? Okay, good. So how could we find the value of log 30 if the 3 button is missing on our calculator? Go ahead.
Log 15 plus log 2.
You got it. Did anybody get something different? Great. Good job, you guys. Now, just to give you some more explanation, this third table here doesn't actually have, oh, never mind. We're not ready for me to say that yet. Pretend the last 10 seconds didn't happen. Okay, did anybody get the pattern for the second one? Okay, not Josh, I want someone new. Carter?
It's just you divide them.
Good. It's the same thing, but you divide them. Perfect, Carter. So again, hopefully you got these were the same, and those were the same. This is called our product rule for logs. And this one's called our quotient rule for logs. Okay, so this one would be like a similar thing, right? Like log, what did you guys come up with?
60 and then minus log 2.
Great. I kept thinking 90 and 3, and then I'm like, wait a minute, that uses the 3 button. Okay, that's a good example. There's lots of things that could have worked for that, right? But as long as they divide to be 30, that's all you need, okay? Very good. I want to talk about 7 really fast, but let's do it together. A student noticed that the log of 1/2 gave him the same result as the negative log 2. So I just want to go through our rules from today and last time to talk about why that makes sense. So if I used our quotient rule that we just did, I'd split that into log 1 minus log 2, right? Anybody remember from last time what log 1 is? What is it, Kevin? 0, right? Scoot it up. Oh, we're still on 7. So log 1 is 0 minus log 2. Because remember, if I'm trying to make something with an exponent turn into 1, it has to be 0, okay? And then, so that hopefully will show you how we get from here to here. Those should be the same thing, okay? This table, when I tried it with my other Sec 3 class, it was a little confusing, so I think I'm going to go through the idea a different way in the area next to it with you guys, okay? Just because the way the table is set up is a little confusing for me, and if it's confusing for me, then it's probably confusing for you guys. Okay, so let's say I have, first I have to read the question because it's hilarious to me. Okay, Saul was practicing evaluating logarithms on his calculator on Halloween. After he had finished all the calculations, he was startled by the results. He was sure that a ghost had haunted his calculator and broken it. What do you think? Can you make sense of his results, or is his calculator haunted? Dun, dun, dun. Okay, let's find out. So, but again, I'm going to write what he was perusing on Halloween alone, right? Over here, because it's a little confusing here for me. So he typed in log 5 plus log 5. Okay. And using our rule, we just learned that's the same as log 5 times 5.
Log 25 or 2 log 5.
Ah, so log 25 or 5 squared, right? And then 2 log 5. Because, right, if I have the same thing being added, can't I say that there's 2 of them, right? Okay, so let's pause on that one, and then I'm going to write this next one here. Log 4 plus log 4 plus log 4. So one way to write that is if I have the three of the same thing being added together. Thank you.
Are they here?
They are here, yeah. But can they come during homework time instead of right now?
I don't know.
That's okay. That's fine.
You'd have to call the counseling office for that.
I'll ask. Thank you so much. Log 4. So this one is just like basic addition properties, right? This one here, our new rule would be like I could times them together. So log 4 cubed. Do you guys need one more, or do you think that's enough to see the pattern I'm trying to get you to see? They are the same thing, okay? So then if I wanted you guys to write something that's the same thing to log x to the power of y, could you give me a rule? Okay? Okay, try it on your own for a second. Okay, use those as a pattern. Someone I haven't heard from yet today. Can you raise your hand and tell me if you think you know something that would be equivalent to? Someone I haven't heard from yet today? There's about 27 options. I've heard from Gavin. Isaac.
Is it 4 log x?
Yeah. Because of my poor handwriting, I'm gonna take that. That's supposed to be a y, not a 4. But that's my bad because it looks terrible. But if that was a 4, that would be perfect. But y log x, just so it's like a general rule. Does that make sense? Yeah. Very good. This one is called our power rule. These are the 3 main log rules we got to get memorized eventually. Power rule. Perfect. So let's talk about why this last entry in the table makes sense. Because the coefficient can come up on the inside as an exponent, right? So using that power rule, I can change this to be log 625 to the 1/2, because that can come up as an exponent. And remember we reviewed last time that a fraction exponent is like a square root. So those 3 are all equivalent.